Hello students, this is going to be a short test review on how to solve quadratics in a variety of methods. So the first thing to remember is that when you're solving a quadratic, you are trying to find the value of x when y is equal to 0. So graphically, you are trying to find the values of x where the parabola crosses the x-axis. So if it was like this, these points are the solutions, or the zeros, or the x-intercepts. Those are the points we're trying to find. So you have this prep packet that we started today in class, and I'm going to go through it, and I'm going to do a bunch of the problems so that you can cross-check against what you're doing. So we're going to start with number 4. Number 4 is a solving by factoring problem. So what we're going to do is we're going to make sure that it's set equal to 0. Then we are going to factor the equation. We're going to set each factor equal to 0 and solve them for x. So first thing we do, is it set equal to 0? Yes. So we can keep going. Next step, factor the equation. I'm trying to think of numbers that multiply out to 12 that add up to -8. And those numbers are going to be n minus 6, n minus 2. -6 times -2 is positive 12. -6 plus -2 is -8. Now I take each factor and set it equal to 0. This is the application of the zero product property. I get n equals positive 6, n equals positive 2. The convention is to actually write this as s is equal to curly bracket 2 comma 6. This states that the solution set contains the values 2 and 6. That's the convention. That's how Paul would write the answer in the back of the book. The next problem we're going to look at is number 7. Number 7 is a little bit more complicated, but it's not really any harder once you realize what the trick is. So x squared minus 4x minus 3 equals -3. So remember, first thing we got to do, is this equal to 0? It's not, so we have to add 3 to both sides of the equation. We get x squared minus 4x equals 0. This is the point where some students might be confused. How do I solve this now? But remember, we can also factor out the greatest common factor from the terms. So in this case, the greatest common factor of x squared and -4x is x. So I pull an x out, and I have left with x minus 4 is equal to 0. Now I can still apply the same zero product property, x equals 0. X minus 4 equals 0. I'm still setting each factor equal to 0, and I'm going to get x equals 0. There's nothing to do here. And over here, I'm going to get x equals positive 4. So now my answer would be like the solution set is equal to 0 comma 4. I know that problem's a little bit confusing, but you got to remember that there's no rule that says like the parabola can't go through the point 0 comma 0. So what you really have here is a parabola that goes there and goes through here. It might look something kind of like this. I don't exactly know what it looks like. I'm just sketching the curve to help with the concept. Let's continue to problem 8. Number 8 brings up something that you also learned previously this year, the concept of the difference of two squares. So we have p squared minus 17 equals -8. And again, are we equal to 0? We must be set equal to 0, and since we're not, we add 8 to both sides p squared minus 9 is equal to 0. You got to be able to recognize that this is a difference of two squares. P squared is a perfect square, 9 is a perfect square, and we're doing subtraction between the two, so it's a difference. This is a difference of two squares. So all differences of two squares factor into conjugate binomials, p plus 3, p minus 3. Two identical factors except for the signs. So now we set each factor equal to 0, and we're going to get p is equal to 3, and we're going to get p is equal to negative 3. So our solution set contains the two values 3, negative 3. We're going to continue to problem 9 and then 10. Number 9. X squared minus x plus 7 equals 7. Whoops. Equals 7. So, first thing we do, set it equal to 0. Subtract 7, subtract 7. X squared minus x is equal to 0. Again, this is kind of like the problem above. It's kind of like problem 7. We are at a similar position here. These steps are very, very similar steps. In the first problem, we were left with x squared minus 4x equals 0. Now we have x squared minus x equals 0. So we just have to try to figure out how to deal with that. And it's simple. We just factor out the x. Just like we did before, we factor out the x. What happens when you factor out an x from an x? You're left with 1. So we end up with the factors of x times x minus 1 equals 0. I can set each factor equal to 0, x equals 0, x minus 1 equals 0, and then we're going to get x is equal to 0. There's nothing to do there, and we get x is equal to positive 1. So our solution set contains the values 0, 1. And just like I gave as an example before, if we were drawing a sketch of this curve, it would look something kind of like this, where here's 1 and here's 0, and it's a little teeny parabola that goes through the point 0, 0, and x is equal to 1. Let's do 10. B squared minus 12 equals negative 8. First thing to do, set it equal to 0. We add 8 to both sides. Negative 12 plus 8 is negative 4. So we have b squared minus 4 is equal to 0. That's a difference of two squares. Therefore, it factors into conjugate binomials. We have b plus 2, b minus 2. And we're going to end up then with b is equal to 2, negative 2. The solution set is negative 2, 2. The convention would be to write the values in the solution set in order of increasing size, from the smallest to the largest. We're going to skip ahead now to problem 14. 14, b squared minus 7 equals 57. We're going to solve this by taking square roots. So we have to add 7 to both sides. So you notice here we're deviating from our sort of standard of setting it equal to 0. But that's because we notice that there is no middle term here. We just have the squared term. So I don't need to have to do any algebra really to get b alone. I'm just going to move my 7 over. I get b squared is equal to 64. I take the square root of both sides, and I'm going to get b is equal to plus or minus 8. So my solution set contains the values negative 8 and 8. If it's a little hard for you to think about doing it in a different way, you could solve this by setting it equal to 0. A setting it equal to 0 method would be like b squared minus 7 equals 57. Now we set it equal to 0 by subtracting 57 from both sides. So negative 7 minus 57 is negative 64. And at this point, it's a difference of two squares, and it factors into conjugate binomials. B plus 8, b minus 8 is equal to 0, and therefore we get b is equal to negative 8, 8. And the solution set is equal to negative 8, 8. It's exactly the same problem. It's almost the exact same work, but we're approaching it from a different perspective. This method over here, this is an approach that uses the process of taking square roots. And over here we have an approach that uses the process of factoring. It doesn't really matter. It's exactly the same, whichever makes better sense to you. We're going to continue to problem 16. Problem 16 is kind of like problem 14. We have 36x squared minus 1 equals 99. So again, I could do this in either way. I could solve this by taking square roots. I could solve this by factoring and applying the difference of two squares rule. I'm going to solve it by taking square roots because it's easier. Add 1, 36x squared is equal to 100. Take the square root of both sides. The square root of 36x squared is, we just take the square root of each member. So we got 6x is equal to plus or minus 10. And now I divide, and I get x is equal to positive 10/6 or negative 10/6. And if I'm being thoughtful, I'm going to reduce my fractions. So this would become 5/3 or negative 5/3. And if I don't like fractions and I prefer decimals, what is this? This is 1 2/3 or negative 1 2/3, or written in decimal notation 1.66 repeating, negative 1.66 repeating. Okay, let's continue on to problems in which we are asked to complete the square. I'm going to do 2. I've selected these 2 because they're good examples of what could show up on a test or a quiz. We're going to start with number 19. X squared minus 2x minus 42 equals 6. So, first step, we are going to move c to the other side. So we're going to add 42 to both sides of the equation. And we get x squared minus 2x is equal to 48. Now we are going to complete the square. We are going to add b over 2 squared. So we take b over 2, so that's 2 over 2, and square it, and we add that to both sides. So I'm going to actually write that out. b is negative 2 divided by 2 squared is equal to 48. And I'll write it over here too, because we add it to both sides of the equation. Now, I only really wrote it all out like that so that if you were watching and reading along, you can see exactly what I did. I'm going to simplify this now. Negative 2 divided by 2 is negative 1, and negative 1 squared is just 1. So we really just have x squared minus 2x plus 1 is equal to 48 plus 1, which is, of course, 49. And this can factor into x minus 1 times x minus 1, or, stated a little more efficiently, x minus 1 squared equals 49. And now again, we can solve this by taking square roots. We take the square root of both sides. We're going to end up with x minus 1 equals plus or minus 7. Therefore, x is equal to plus or minus 7 plus 1. So what is that? Solution set includes the values 8 and negative 6. Not too bad. We're going to move on to problem 23 now. Now, if you note in the worksheet, there's a little statement. Compare the following questions to the questions you just answered. What's different? Does that difference require you to add an additional step? If you look at 23, 24, 25, and 26, you'll notice that in each of those problems, a is no longer equal to 1. In 19, 20, 21, and 22, a was equal to 1. Because a is not equal to 1, it requires us to add a step at the beginning of the problem in which we divide through by a. So let's do 23. 6r squared plus 12r minus 88 equals 2. Now, technically, it does not really matter if you move C or divide through by A first. Like, it doesn't matter. You can do whichever one you want first. But if I'm going to look right now, if I divide through by A right now, it's going to get really messy because I'm going to have to do 88 divided by 6 and 2 divided by 6, and that's going to be equal to a third, and the other thing's going to be something a third, and I don't want to deal with that. So I'm going to move C first because it makes my life easier. Sometimes it might not matter. Let's move C. So we add 88 to both sides of the equation. We get 6r squared plus 12r is equal to 90. Now I'm going to divide through by 6, which is pretty easy. 6 divided by 6 is obviously 1. 12 divided by 6 is 2. And 90 divided by 6 is 15. Now I'm going to complete the square. I'm going to add the b over 2 squared value to both sides of the equation. So the b over 2, it's just 2 over 2 squared. And I'm going to add that to both sides of the equation. We get r squared plus 2r plus 1 is equal to 16. And at this point, this is pretty straightforward. R plus 1 squared is equal to 16. We solve it by taking square roots. R plus 1, square root of r plus 1 squared is equal to square root of 16. We get r plus 1 is equal to plus or minus 4. We subtract r1. We get r equals plus or minus 4 minus 1. Therefore, my solution set contains the values -3, -5. The last thing in this packet was some graphing problems. I'm going to do number 29 because it's a pretty good example of what you'd be expected to do on a test. On a test, I'm not going to put in a wacky problem that has a lot of points to the half unit or other fractional units. I'm not going to put in something that requires you to draw a really big grid. It's all going to be manageable within a sort of like plus 10 in every direction grid. So let's do 29. First thing I'm going to do is write the equation y equals x squared plus 8x plus 15. And then I'm also going to draw in my grid. Now, you obviously aren't drawing a grid because I provided you with one. But if I didn't provide you with one, I would draw the grid right away. And I would make it nice and big. I'd give yourself lots of space because it'll make your life easier. But maybe not too big because you don't want to have to take up the whole page. Remember, a well-labeled grid includes arrowheads on each axis, and it includes the x and the y label. And if you want to mark out your 5s, you can, but I don't really care. But you should do something that shows your scale so that it's clear that one box is equal to 1 unit or one box is equal to 2 units, whatever you're choosing to do. Okay, first thing to do is to plot the point 15, and that's way out there. So I'm going to kind of ignore it for now, but I know this is the y-intercept. So I'm just going to remember that, and I'm not going to worry about that right now, but I can read it right away. Next thing I'm going to do is I'm going to factor to figure out where the x-intercepts are. So 0 equals x squared plus 8x plus 15. 0 is equal to x plus 3, x plus 5. Therefore, my roots are -3, -5. I'm going to plot them. Okay. Now I know that the vertex must lie somewhere on this line of symmetry. The vertex must be halfway between the two, and I know that the value of x here is x is equal to -4. That is the value of my line of symmetry. So I'm going to take -4, I'm going to plug it in for x, I'm going to see what y is equal to when x is equal to -4. Y is equal to x squared plus 8x plus 15. Now I put in my -4. -4 squared plus 8 times -4 plus 15. This is going to be 16 minus 32 plus 15. So 16 minus 32 is negative 16, plus 15 is 1. So y is equal to 1. When x is equal to negative 4, y is equal to 1. Therefore, the vertex is at negative 4, comma 1. I can plot my point there. Now, one thing that you may have noticed, I've taught it to some people individually walking around, but you may have noticed is that parabolas often seem to follow this symmetrical pattern, that if you go over 1, you go up 1. The next time, if you go over 1, you go up 3. So we went up 1, over 1, and we go up over 1, up 3, and we could go over 1, up 5, and parabolas always follow this pattern. Now, this pattern's easiest to follow if a is equal to 1, but we notice that it is, and the pattern still applies when a is not equal to 1, but it scales. So if maybe a was equal to 2, everything would be off by like a factor of 2. But it's a good pattern to apply, and it's especially easy to when a is equal to 1. So I'm going to sketch in my curve. And remember, I'm going to make an effort to make it a U-shaped curve, not a V-shaped curve. Parabolas do not have V-shaped graphs. They have U-shaped graphs. So just make an effort. My computer, I must have accidentally hit the stop recording button, but all you missed me saying was that the parabolas do not have V-shaped curves. They have U-shaped curves, so make sure you make your best effort. Now, that's everything that's going to be on this assessment. We're going to learn something new tomorrow on Wednesday, which is called the quadratic formula. I am not going to put the quadratic formula on Friday's quiz. The quadratic formula will come in a quiz the following week on Monday or Tuesday. Make sure you check all the problems in the packet. I'm happy to provide you with the answer key, and otherwise, good luck. Okay.